Today I felt like doing another microbit project, and I thought I'd build some tiny traffic lights. So to test the software I could use these LEDs built into the display. So if I said that was red and this was amber and that was green, so I could test the software, and then once the software was working I could actually build some external lights to connect to here. So actual red, green, blue, red, amber, green LEDs, and attach them to 3 of the output pins here. So I mean there are kits that exist for making traffic lights, but a lot of them seem to be really quite expensive. I mean, I saw one the other day that was about £15, so I thought I would just go in my box of components, find a few LEDs. I've got some old used LEDs here which I can reuse for this. I've got a little bit of strip board which I can mount them on, and these resistors which are 39 ohms, which should be about the right level of resistance for the microbit, which has got 3 volts, driving an LED. You probably can get away with driving an LED directly from the microbit pins, but it's a good idea with LEDs to give them a current limiting resistor, because there is a possibility that they can draw more and more current until they actually get destroyed. So there's the components I'm going to use. I've also got a little bit of black card which I'll probably put on the front so that you can just see the lights and not all the components. And so before we get to the actual physical construction, I'm going to write some software and just test it using the built-in display. So let's do that. Let's switch to the PC and look at some Python. So on the PC here I'm using this editor called Mu, which is quite nice. You can download this for free, and it's quite good for writing in MicroPython for the microbit, because you can edit the software and then you can press the flash button which will download your code. It compiles it and downloads it onto your microbit. And also the other thing that's neat is that if you open the REPL, hang on, if I plug in the microbit I'll be able to demonstrate this. Okay, so the microbit's connected. If I hit REPL, then what you can do here is you can actually directly talk to the microbit, and so type things in directly. So you can say 5 plus 4 and it calculates it and gives you the answer directly back. So that's quite nice sometimes for testing things. So looking at what I want to do here with in terms of the traffic lights, so this is the skeleton of the program that I'm going to have here. So this class light is what's going to implement my traffic lights, and so the main part of the program I create an instance of light, and then I go into this permanent loop while true, and I'll do show the lights, so show one pattern of lights, and then wait for 1.5 seconds, and then light.next will choose the next phase of the traffic lights before we go back to the beginning of the loop, and we then show the next phase of the traffic lights. So we'll go around this loop forever, showing all 4 phases of the traffic lights 1.5 seconds apart. Okay, so the main thing is how do we actually fill in the class here and define the functionality that we want? Well, this is just an empty class at the moment, so we'll use the special word pass just to make the program syntactically complete. But we actually need some code in here to implement the lights. So first of all, what we need is a constructor. So we need to initialize the things we're going to use in the program. So I'm going to define a list called phases, and whoops, what I'm going to put in here the names of the phases. red amber, green, amber. So those are the 4 phases of traffic lights. I'm going to represent the actual phase by a number, which will be from 0 to 3. So I'll start with the red phase. So in other words, this will be 0, this will be 1, this will be 2, and this will be 3. And as you'll see in a minute, I'm going to use modulo arithmetic, so that instead of counting then to 4, it will wrap back and count 0 again. So we'll see how that works. Also, I'm going to create something called old phase, which is basically remembering the previous phase of the traffic lights, and I'll need that to switch lights off. So that's the initialization, and so now I'll define next, which is one of those functions that I need. Oh, hang on, I realise I've left something out. I need to put self in here. Okay, so next is the function that's going to move from one phase to the next. So this is where I'll save the old phase. Whoops. Self.old phase. Let's select that. Equals self.phase. And then we've got self.phase. Phase plus 1, and then we're going to go modulo 4. So this is the trick that I was talking about. So when you actually get to 4, it switches back to 0 again. So that will alternate phase through 0 to 3 and then back to 0 again, and the old phase will always be one phase behind, so I can use that to switch off the lights from the previous phase. Then we'll define something called show, so here what I'm going to do is I'm going to get the name of the old phase, so that's going to look up in the list here phases using the number 0 to 3. It's going to look up the name, so we'll have old phase name will be red or red amber and so on, and I want to use that to switch off the lights from the previous phase. So I'm going to define this function light mode. I'm going to define in a second, but I just wanted to show you the structure of it. So, and then similarly, the current phase, I'll get the phase name. Whoops, I need to get that lined up because Python is very fussy about layout. And again, we're going to call light mode, and this time I'm going to pass in something other than 0 to light it. So the 9 is actually setting the brightness, as you'll see in a minute, because I'm using going to use a built-in function called set pixel. So there we go. So when I call show, which I do at the beginning of the loop here, what's going to happen is that the lights from the previous phase are going to switch off, and then the lights for the new phase will switch on. So that's what I mean by show. And then finally, let's define light mode. Oops, gone into uppercase. Again, you need to pass in self as the first parameter. Then we're going to go phase name, and the final parameter is the brightness, so I'll call that on off. And now, so I'm going to do if phase name is red. I'll do display set pixel. So display is a built-in function in MicroPython. You see at the top here I've said from microbit, which is a special library for the microbit. So I say from microbit import star, which means everything, and one of the things that it imports is this display and all of the sub functions that belong to display. So I'm going to say set pixel I'm going to go XY00, which is the top left hand corner of the microbit display. So that's going to be symbolizing my red while I test the software. And we'll pass in the on off, which you remember from the last function is either 0 or 9, so that means off or bright basically. So that's going to be my red phase. Now I'm going to do something similar for the next phase. So red amber, this needs 2 lights switched on, so the top 2, so the 0, 0 was the red, but I also need 0, 1, so that's 1 down from the top left hand corner, so that'll be my amber phase. And then we get to the green phase. And that will be offset 2, so the third LED down, in other words. And then we're going to go back to amber. So let's change that to amber, and this time we don't need that red one there, so we'll take that out. And that should be all that we need. So we got the red phase, which is gonna control the top LED. We've got red amber, which is going to light or switch off the top 2 LEDs. We've got green, which is the third LED down, and then we've got amber on its own, which is again the middle LED, so 1 down from the top. Oh, I should actually make that into else if, because only one of these is going to run in any one phase. Okay, so that should be my program complete. And what I'll do now is well, save first of all, save that onto disk, and we'll give that a test. So let's hit the flash button to download the code. Okay, so that's running now. So we've got the green phase there, amber, red, red and amber, green. So that's now alternating around all 4 phases over and over again. So with that basically functional, I'm going to now get the soldering iron out and actually make up the external LED board, and we'll test that also. So first of all, I've poked some holes in this black card so I can mount the LEDs through the front, and then the bit of perf board will go behind, and I'll be able to solder it on there. So I'm going to That's how I'm going to do that. So LEDs are polarized, and the way that you can tell which is the positive and which is the negative is, well, if you've still got the original legs on it, you can see the longer one they always make positive. But actually, if you look in, not sure how well we can see this on the camera, but if you look in actually through the plastic, you can see that there's a small contact there, which is actually the anode, and there's a large one which is the cathode. So it's not easy to tell with the red one because we're getting a bit of a reflection there, but you can just about make out, I think, that the left hand one is smaller, so that's the anode. So I'll put all the LEDs round the same way. It's a little bit fiddly, this. There we are. So we've got all the LEDs in place against the black baffle. So I'll just solder those on. And now I need to put some resistors on here also. So we'll put the resistors on the back so they're not visible. So you can see what I've gone for here. I've just soldered the resistor on one side of the LED. It doesn't really matter which side of the LED the resistor goes, it just needs to be in series. And what I'll do is the other end of the resistors I'll run down to the bottom here, and we'll connect some wires to it so that we can drive it from the microbit. So what I decided to do is cut down one of these DuPont cables, because it's going to be quite convenient for me to plug in the wires using these type of connectors. So you see I've connected the so I've got an orange, yellow, green, which are nearly the right colours, and they were all together in the loom, so I thought I'd go for that. So we've got the orange connected to one side of the red LED, the yellow connected to one side of the amber LED, and then the green connected to one side of the green LED. And then on the other side all the resistors have been all soldered together, and this is my common earth connection. So the 0 volts connection, I chose black. So we'll just give that a quick test, and we'll put 3 volts on these wires in turn. So we've got the green and the amber. Oh, sorry, that's the red. Of course, got the orange wire going to red, and then finally the yellow wire goes to amber. There we are. So that's working, and so I can connect that up to the microbit. I'm going to use one of these adapter boards. I think this was from ProtoPic, so I'm going to use that. So it's quite nice. You can plug in onto the edge connector here, and then you can use the DuPont cables to connect it to other things. You can plug in the DuPonts on that strip of headers there. Black goes to ground, and we'll go red to 0. Yellow to 1, so amber to 1, and then green to 2, P2. So those are the three big connectors on the microbit. Obviously it's not doing anything at the moment because at the moment the code only drives the LEDs on the display, so we need to go back into Python, make a small change, and add in the switching of pins P0, P1, P2. So I'm going to leave the existing code, so I'm going to still have it working on the microbit display, but I'm just going to add some code in here to do the switching of the pins on the interface. So first of all we'll do the red, so that's pin 0, so we say pin 0 write digital, and put the value on off in there. Actually that will be 9, won't it? So let's be cleverer than that. Say on off is greater than 0. Let's do that. That should work. And then so red amber, we've got the red on, but we also want the amber on, which is pin 1. We'll want the pin 1 on the amber phase here also. And then finally, let's get rid of that. Finally we'll have the green phase, which is pin 2. Okay, so that should do it. We don't need to change anything else in the code down here. So we got red, we'll switch pin 0, red amber will switch pin 0, pin 1, and green will switch pin 2, amber switching only pin 1. So let's reflash it and have a go. And there we go. So we now got the external traffic lights. So we got starting with the red phase, going red, amber, green, back to amber, and then back to red. So that's it. We've built our UK style traffic lights with 3 LEDs and 3 resistors and a bit of code in Python. Okay, so thanks very much for watching. Obviously like, share and subscribe if you like these kind of videos, and we'll see you in the next video for more microbit and more Python.